uh, the concept is counterproof, the same thing. Counterproof is a noun form word. So what is this actually? The thing is, sometimes we mm, the process of uh, proving a theory uh, wrong. So this is actually called counterproof or disprove. That is, somehow you prove that a theory wrong. Disprove means also proving a theory. Disprove is also proving a theory, but it is actually the process of proving a theory wrong. So, say I'm giving one example. Uh, say disprove that there is a theory. Say it is like uh, square of a number is uh, greater or uh, equal to the original number. So this is the theory, and you will disprove this. So do you think it is possible to disprove? That means you can show that the theory is wrong. Is that okay? Do you understand my question?
Yes.
So is it correct?
And it's not possible.
No, sir. Sir, it's not correct, sir.
So how can you show that it is not correct? How can you show that?
Sir, if I do 0.5 square, then the number is
Yes, yes. That is the point. So this theory is not correct actually. So how it is not correct? You will give an example. So if you take an example of zero point 0.5, that will be the proof that the theory is wrong. So this is called disprove. I'm giving you another example. Show the counter proof of, say, I'm giving another theory. Let me just make it. I'm thinking. So what can be the theory? So it is sum of uh, two numbers is even. So this is another example. Okay. So in this way, you can take many or think many examples. So how can you prove that? If you think about the first one, you will write like the the given theory is wrong or not correct. Okay, when we take 0.5, when we take 0.5 as a number, we get 0.5 square is 0.25 which is uh, which is not greater or equal to 0.5. So it is disproved. So it is disproved. So that's it. You can just make your answer like that. And the example point 5, the example point 5, this is called counter example. This is called counter example. So any example, any one example will be enough. If you want to say that the theory is wrong, then one example is enough. One example is enough. You can say that the theory is wrong. If you want to say one theory is correct, then you have to show that for every situation it is correct. Okay, so this is another important concept. Proving a theory is correct if you can show that the theory is correct for every situation. And proving a theory is wrong, it is enough if you can show that for one counter example, the theory is wrong. So that will be enough. So this is the thing actually I did not talk in the chapter of uh, methods of proof. So how you can prove the second example, the second one, how you can prove it? This is also by taking counter example. Okay, so this is also by taking counter example. So you can take, okay, you can write it like, okay, let us uh, take two one even, okay, any and let us take one even, any even number, and one odd number. Okay, so one even number maybe 2, one odd number uh, maybe 3. Okay, so as counter examples, so if we take one even number and one odd number as counter examples, then 2 plus 3 is 5, which is not even number, So you can say, okay, the counter proof is given, or you can say disprove done. Okay, you can say the theory is disproved. Therefore, it is disproved. It is disproved means you have proven that the theory is wrong. So that's all. Okay. So you can write in your own words, in your own language, no problem. But the concept is this, and the word is disprove, or sometimes we can use counter proof. Is that okay? Any question from this, or can I move to the new chapter?
So you can move on.
It's okay, sir.
Yes, this is just a concept. That's it. So if I say, okay, all Noakhali people will eat and live, then in that class somebody said, no sir, it may be wrong. So how can you disprove that? It may be wrong, so how can you disprove? You will give a counter example. You will give a counter example. How? You invite your friend from Noakhali and then you show. Okay, then you show. Then see, this is my friend from Noakhali. He is having food and he is not leaving the place. So this is the counter example. Then you see, so the theory is disproved. Is that okay? You understand what I'm saying?
Yes, sir.
So let us move to the next chapter. As a whole, the chapter is called combinatorics. So the first thing what we discuss is called counting principle. So includes counting principle is one thing, and it has one example or one uh, theory called pigeonhole principle. So we will talk about this today, and there are other things we will discuss. Say this one, the other one. Okay. So we have six pigeons. Then what will happen? The theory says if there are five holes, okay, if there are five holes and uh, 5 plus 1, that means 6, okay, pigeons, then there will be at least one hole where more than one pigeon will rest, or I can say there will be more than one pigeon. There will be more than one pigeon in at least one hole. Okay, so it is simple to say. So this is the this is the pigeonhole principle. This is the pigeonhole principle, or you can say theory. So now the point is, this is not general theory. It is just 5 hole and 6 pigeon like that. So what is the meaning of this? Meaning of this is you can keep one pigeon in one hole, and you can think another pigeon in another hole. So 1, 2, 3, 4, 5. Then there will be one more pigeon, extra pigeon. So you can keep it somewhere, maybe here, or maybe here, or maybe here. In any hole you can put, but in that case it will be more than one pigeon. So if you think that okay, there is no pigeon in one hole, and there is 3 pigeon in another hole, that is also possible. So it is not the theory that there will be 0 pigeon in one hole. It is not a problem in the theory. The theory says uh, at least one hole will be there where you will find more than one pigeon. So why more than one? Because it is plus 1. If it is plus 2, then maybe more than 2 pigeon, like that. So this is one theory which is called pigeonhole theory or pigeonhole principle, but it is not general theory. It is not general theory. So if we want to know the general theory, Then let me write out the general theory. So gena, sorry, generalized pigeonhole principle. So what is the generalized pigeonhole principle? So generalized principle says that uh, if there is n holes and n plus k pigeons, then mm, okay, so let me write a little different way. If there is k holes, let me write k holes. Let me make it simple. K holes and n pigeons. So n is bigger. Okay, n is bigger. N is bigger. So I can write where n is greater than k. So how many bigger does not matter. Maybe 5 more, 2 more, 3 more. That means pigeon is more in number and hole is less in number. So this is the situation. Then uh, there is at least one hole where n by k pigeons where uh, where minimum, let me write minimum n by k pigeons lies, where there will be minimum I will write something by hand pigeons. So what is this thing? I will write something in this gap. So the thing is, I will write it like so. Do you see this correctly? Do you see my symbol? It is n by k. It is n by k, but there is a special kind of bracket. So this is called ceiling. This is called ceiling. This is called ceiling of n by k. Okay, let me write it here. Then it will be fine. It is called ceiling of n by k. So n is a number, k is a number, and n by k is a number, and this number is called ceiling of n by k. So do you understand what is ceiling?
The ceiling is if there is any fractional number, then we'll take the next greater number.
Exactly. Exactly. It is correct. The next whole number. Next whole number. So let me give you example. So how? Say the example is, say we are dividing 30 by say 7. Then 30 by 7 is what? 30 by 7 is 5, no 5, not 5, 4. 4 point something, right? 30 by 7 is 4.28, something like this. So if this is 30 by 7, what will be the ceiling of 30 by 7? So ceiling of 30 by 7 will be ceiling of 4.28, and it will be
5.
5. It will be 5. So ceiling of any number is the next whole number. Actually, this is the next whole number. So this is called ceiling, and floor means the previous whole number. So it is called next whole number, and another word is floor. Floor is the previous whole number. So we are not using floor here, we are using the ceiling. So in this case, the ceiling will be used. So it is called the generalized pigeonhole principle. This is called generalized pigeonhole principle. So generalized pigeonhole principle, we are taking any k, any n, and definitely number of pigeon is higher than n by k, then I mean generalized like this. So this is the situation. Now we can give example so that it will be clear or easy to understand. So let us give one example like uh, say I'm writing one thing here. Say you have 55 students in this class. So in a class of 55 students, how many will have birth day, say birthdays in a same day? Same day means Sunday, Monday, Tuesday. These are the days. So in this case, uh, 55 is the number of pigeons. 55 is the number of pigeons. So in this case, we can think n as 55. And same day, so the question will come, how many days? So that will be, how many days? That will be 7 days. That will be 7 days. So 55 student is actually your n, and 7, that is actually your k. That means you are putting the persons like, okay, so these are the days, okay, say Sunday and Monday and Tuesday and Wednesday and uh, Thursday and Friday and Saturday. So 1, 2, 3, 4, 5, 6, 7, right? So we are putting the persons like, okay, somebody has the birthday on Sunday, so 1. Somebody has birthday on Monday, okay, 1. And Tuesday, Wednesday, another Tuesday, another Monday, another Wednesday, another Thursday, Friday, okay, Sunday, another, like that. So we are asking the birthdays. So there are many people. How many total? Total 55. So if you just ask the questions, okay, what is your birthday? What is your birthday? Is it Monday or Sunday or Tuesday? Then you will see how many will be in one day. So how many will be in one day? This is actually ceiling of n by k. This is actually ceiling of n by k. That is our question. So we can find it by this theory. So what will be this situation here? We can do the calculation. Calculation is very simple, straight cut. Calculation is like, you will say here 10 here the n is 55 and k is 7. You can write because there are 7 days. Okay, you can write the uh, uh, explanation. So in one day, okay, uh, a number of students having birthday will be, so let me erase this part. Having birthday will be 10 by k ceiling. So this will be 55 by k means 7 ceiling. So it will be ceiling of 7 point
So 7.8 something.
7.8 something. Say 7.86. Okay, so this is the ceiling of 7.8. That means 8. So you will see 8 persons. There will be 8 persons who has at least. I mean, there may be 9 also. There may be 9 also, because I mean, it is written minimum. Okay, at least 8 person will be there who has the birthday on a same day. Now, another question may come that same day is which day? Is it 8 person on Sunday, or is it 8 person on Saturday? No, this is not possible to say. This is not possible to say from the theory. The theory is saying only the number of persons who has the birthday on the same day. So there will be 8 persons like that. Is that okay? Do you understand this now?
Yes.
Sir,
Yes.
if we have 8 remaining, sir, that means 56 হয়ে যায় না স্যার?
I do not understand. Yes. So this
স্যার
this
যদি
is
আমাদের স্যার যদি আমাদের 8 বাকি থাকে তার মানে হচ্ছে 56 হয়ে যায় না স্যার?
no 55 divided by the pigeon number divided by the whole number. Whatever the answer you are getting, you will get the next value. Next value, that means 7 into 8 equal to 56. This is not our target. Our target is how many persons we will have in one birthday. Let me give you another example, then it will be clear maybe. Let me give you another example. How many persons must be, okay, or should be in a I mean gathering, so that their uh, their names will start with a certain letter. I'm writing that there will be minimum 10 persons whose names start with a certain letter. Now, what do you think? Do you understand the question? The question is, say in a room there are some persons, and how many persons you need, how many persons should be in that room, so that you will get, or you will see, at least minimum means at least 10 persons whose names start with a certain letter. So maybe start with S, or maybe start with A or B, whatever letter. What is the letter we do not know, but this is a calculation. We can say that how many persons should be in that room. So in this example, you will write what is your N, what is your K. So what do you think? What is your N?
Sir, 10.
No, N is the number of pigeons. N is the all people gathering in that room. So we do not know what is N. We will find out. You understand what I'm saying? So you, every time you think like that, okay, whole and pigeon, whole and pigeon. So you are keeping pigeon in the hole. So in one hole there is a pigeon, there is a pigeon, there is a pigeon, like that. So in this case, person is the number of pigeons. We do not know how many. That is our question. That is our question. Actually, we 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 find out. We need to know. We need to know. We need to find n here. So this is our first thing. And do we know what is our K?
Yes, sir. 26 letters.
What is our K?
The letters. So should it be 26 because not every letter starts for a name is used.
It should be 26. Yes. So the number of holes is 26. Okay. We will take 26. You can think, okay, there is no name with X. Maybe possible, but we are not thinking about that. Just 26 letters in English. Okay, fine. So this is our number of holes. And then you already know 10. So what is this actually? What is 10?
So 10 is the n by k.
N by K, not only N by K, ceiling. It is, yes, not only N by K, it is ceiling of N by K. Ceiling of N by K is, it is given as 10. So this is the thing given. So now you do the calculation next. So what is the calculation? You do not know what is N.
Sir,
And yes,
are you using third brackets or is it used for ceiling?
it is used for ceiling. It is like a third bracket, but it is not in the lower part. There is a breaking in the upside part only. That is why ceiling. This is like that. This is ceiling. Okay. So like the third bracket, lower part is open. Lower part is open. So you do the calculation here, n by 26, and then it is 20. Oh no, not 20. Sorry, right side is 10. It is 10, and now you do the calculation. So, so is it 26 into 10? That is the question. Actually, not. Actually, not. Why not? Why not? Because the 10 was a ceiling number. Actually, the original number was maybe 9 point something. Okay. Maybe 9.1, maybe 9.2, maybe 9.3. We are not sure about that. But anything with 9 point. You understand my logic, right? actually this 10 was a ceiling number, so it was 9.1 or 9.2 or 9.3 or 9.4, something like that.
Yes, sir.
So we cannot really multiply 10 into 26. Then it will be wrong. 10 into 26 is not the correct answer. So it is what?
But
It
there
is
will be at least 9, sir.
at least 9, right? So there will be 26, sorry, 26 into 9, and then at least one more, and then at least one more. So this is the thing. So this 9 is coming from 10. Okay, if you have 5 here, then you will write 4 here, and there will be always plus 1. You plus 1 put here because we need more than 9. So ultimately the answer will be 9 into 26, that is 235. So 236. So that will be the answer, 236. So we need at least 236 people in the room so that we can say that minimum 10% will be in that room, so that everyone has the name with a certain letter. This is for sure. So that's it. This is the theory, and it is the pigeonhole
Sir,
principle. So
I think
we can
with
finish
plus
our class.
it is the 35.
Yeah, you tell me again. It was not
Yeah.
clear.
With plus 1, 26 into 9 plus 1.
Yeah, plus 1 means if you write 26 into 9, that will be, oh no,
235 after adding 1.
okay, after having 1. Okay. So the answer is actually 235, and 26 into 9, it is actually 234, right?
Yes.
Okay, so 234, if you write 234, then what will be n by k? N by k will be 234, n by k will be 234 divided by 9. So no, 26. 234 divided by 26 is actually 9. There is not 9 point something. So if you do not have 9 point something, then why should you write 10? So there may be little more than 26. There may be little more than 26. Now the question comes, why plus 1? So if you write plus 2, that will be also correct. If you write plus 3, that will be also correct. That will be also correct if you write plus 4. But which one I should take logically? I should take the minimum one, because it is written in the question how many persons should be in the room. So how many persons you need actually? Okay, do you need 234 plus 4? No. If you have 234 plus 1, that is also fine. So 235 is also okay, enough. So I mean, in calculation, it is plus 2, plus 3, plus 4 possible, but you will take the minimum one, which is mandatory, which is must. Okay, so that is it. Let us finish our class.